Hi. In this video, we'll cover the first three lessons of the software carpentry Unix shell material. These lessons being the sections generally required by most NESI users to work on the NESI platforms. If you would like to follow along, you can find a link to the Unix shell lessons in the description. The link will take you to the summary and setup page, which will also include a link to the data that we will be using. But what exactly is the Unix shell? Now, the most common means for which humans are interacting with computers nowadays is through graphical user interfaces. This is where instructions are given by things like clicking the mouse or using menu-driven interactions. And while learning to use a GUI is intuitive for most of us, for many workloads, GUIs will scale poorly. They are open to human error and can reduce reproducibility, which is especially important for researchers wanting to publish their results and methods. And this is where tools like the Unix shell come in. So fundamentally, Unix is a unified inode-based file system, the Unix file system, and a set of simple tools, each of which performs a limited, well-defined function. But these tools can then be combined together with an inter-process communication mechanism known as pipes to perform complex tasks, allowing the language to be more powerful than the sum of its parts. This power, along with it being the first portable operating system, which allowed Unix to operate across platforms, is one of the major reasons this language is the de facto tool for many computer scientists and scientific programmers, and has survived for as long as it has, and it will likely continue in its importance for the foreseeable future. Now, for those of you who are looking to follow along with these lessons at home, if you're using a Mac or a Linux, other than downloading the data, you don't need to do anything, as the bash terminal is installed and available by default. You merely need to use the search function to search for terminal. If you're using a Windows computer, you will likely need to use an emulator such as Git for Windows, which is recommended by Software Carpentry Lessons and is provided an installation instruction in the link I mentioned in the description for the setup. Or the Windows subsystem for Linux, which is what I will be using, and we've provided a link to the installation instructions in the description. When you first open up the shell, you'll be presented with a prompt indicating that the shell is waiting for an input from you. This prompt will display a $sign, as you can see here, as well as a text cursor, which is flashing right now, indicating where you're typing. Please note that depending on your setup, the overall prompt might look a little different, but it should have these features, the $sign and the cursor. This area here at the start of the prompt can especially change quite a lot. So don't worry if your prompt doesn't look exactly like this. So let's try our first command, which is ls, which is short for listing. This command will show us the contents of a cut directory. And so let's type ls. And so now we can see the content of this directory. Just to note, if you mistype the command, so for example, if I type ks instead, I'm going to get an error that says command not found. Now let's briefly talk about the data that we're going to be using in this. Since this video is based on the software carpentry Unix lessons, we'll also be using the data from those lessons. If you want to follow along, as mentioned, you can download the data from the summary and setup page of the software carpentry Unix lessons, which a link to is posted in the description. The data that we'll be using belongs to a hypothetical marine biologist named Nell Nemo, who has just returned from a 6-month survey of the North Pacific Gyre, where she's been sampling gelatinous marine life in the Great Pacific Garbage Patch. She has 1,520 samples that she's run through an assay machine to measure the relative abundance of 300 proteins, and she needs to run these 1,520 samples through an imaginary program called goostats.sh. In this video, we will cover how to navigate, create, and manage file and directories using this data. We will also make a second video later covering the remainder of the introduction to Unix shell lessons from the software carpentry material. Now let's talk about navigating files and directories. The part of the operating system responsible for managing files and directories is called the file system. It organizes data into files which hold information, and directories, also known as folders, and which hold other directories as well. Several commands are frequently used for expecting and managing files and directories, and first of these commands that we're going to use is to find out where exactly we are, and that's using a command called pwd, which stands for print working directory. So pwd. So as we can see, I am located in my /home/Anthony directory. So directories are essentially like places. At any time when you're using the shell, you're going to be in exactly one place, which is called our current working directory. Commands will mostly read and write in the current working directory. So knowing where you are before running a command is important, and pwd will show you that. The home directory path will look different on different operating systems. So if you're using a Windows machine with another shell option, you may see something like C/documents and settings /your name, or if you're using a Mac, you might see something like /users /your name, or something different depending on your operating system or the version of your shell client. I am on a Windows machine myself, but I'm using the Windows subsystem for Linux with Ubuntu terminal. And so my path looks quite similar to a Linux user's. Now, to understand what a home directory is, let's have a look at how the file system as a whole is organized. For the sake of this example, we'll be illustrating the file system on our scientist Nell's computer. After this illustration, you'll be learning commands to explore your own file system, which will be constructed in a similar way, but not exactly identical. So let's take a look at Nell's computer. Now, it essentially looks like an upside down tree, with the topmost directory being what is known as the root directory, which is represented by a / character. Inside that directory, there are several other directories, also known as subdirectories. In this example, those being bin, data, users, and tmp or temp. Our hypothetical scientist home directory is in user/users/Nell. And so we know that Nell's home directory is inside the users directory because /users is the first part of the name. Similarly, we know that /users is stored inside the root directory because it's named because it was /. So let's go down into the level, and we can see within the users we have these three other subdirectories which belong to Nell and their colleagues, Imhotep and Larry. Now, let's go back to the terminal. Now, notice looking at the output of the previously run pwd command that there are two meanings for the character /. When it appears in front of a file or directory, it refers to the root directory. However, when it appears as just a separator, as shown here, between home and Anthony, that's what it is. It's just a separator. It's saying from the root directory down to the next level of the directories, which is the home, then down to the next level of directories, which is Anthony. So I am in root/home/Anthony, essentially. Now, typically, when you open up your command prompt, you will be within your home directory by default. Though that might not necessarily be 100% true depending on your setup, but that's okay. You can work from that directory if you really want to. So let's list the contents of the directories again with ls. And so ls prints the names of the files and directories in the current directory, and we can make the output more comprehensible by using what is known as an option. So pretty much all Unix commands have various options available, and these options can alter the function of the command. And so if we type ls-f, the -f option, which is also known as the classify option, will classify the output by adding a marker to each file and directory names to indicate what they are. And so if we do that, we can see all three of these files have a at the end of these, which indicates that they are links. If it has a trailing slash, so if it said desktop /, for example, that would indicate that it is a directory. And if it had a star on the end, that would indicate that it's an executable. Now, here you can see in my home directory, it contains some link files, which are desktop, documents, and C, which are symbolic link files, which I created. They are essentially just shortcuts to other parts of the file system. I won't go into details about how to create some links in this talk, as it's not really in scope. But if you'd like to create your own, you can see an example in step 6 of the Ubuntu LTS terminal setup instructions, which I've included in the link in the description. For the purposes of this video, these are effectively directories. Any names in the output that don't have a classification symbol are just files in the working directory. If your screen gets too cluttered, you can clear your terminal with the clear command. So if I type CLE clear, I'm going to clear the command. And if you want to use previous commands that you've used before, you can also use the arrow keys to scroll through your history up and down. Additionally, another useful tool for searching through your history is the reverse search option, and you can do this by hitting Control at the same time as R, which will bring up the reverse search function, and you can start typing here to find previous commands you ran. So if I type a dash, it's going to show me the last command that included the dash in it, which you can see it's highlighting the dash in the command, which is ls-f. And then I can further type to make it even more specific if that's not exactly what I want. Say if I type an F, it will look for the command that most recently had a dash capital F in it. And you can keep on expanding that way. And if you hit Control R again, it will look back further through your history for older commands that match that. So if I type enter, it will just enter that command without me having to type the full command. ls has a lot of other options that you can use other than just dash capital F, but there are two common ways that you can find out how to use a command and what options it accepts. Depending on what environment you have, you might find that only one of these ways works. So the first of these is with dash dash help. So if I type ls dash dash help, it will print the help screen, and I'll be able to scroll up through my history and look at the various options and what they do. The alternative option is also to use the man command. So if I type man ls, so man for manual, on the command ls, it will now open up essentially the same thing, but in a text viewer. And I can scroll through it with the arrow keys, but I can also search through this viewer. So for example, if I wanted to find the dash F command, I could type slash and then dash F and then hit enter, and it will find the first instance that matches that. So dash capital F. And as you can see, that dash capital F has an alternative form, which is dash dash classify. Generally, when typing commands, so pretty much all the options you can see here, almost all of them will have a long form. And generally, when typing commands, though, you will use the short form. However, you may want to use the long form if you're trying to have more clarity in what the command is doing, potentially showing other users what they're doing. Now, to exit out of the screen, you just hit Q, and then we're out. If you try to use an option that doesn't exist, you're going to get an error. So if I type ls-j, I get an error that says invalid option -j. Now, before we look at more commands, all Unix commands follow a standard format. So let's formalize some terminology here. Now, consider the command here as a general example of a command which we will use to dissect into its components parts. So first, we have the $, which is the prompt, which is where you'll be typing the command. You don't really need to know that much about the prompt, except that it's there. The next part of the command is the command itself. In this case, it's just the ls command that we've been using. And so this is the command that will be used. The next section of the command is what is known as the option. And this is where you enter the various options that alter the functionality of the command. In this case, we are using the -S option on the ls command, which will make it classify files into types. And then finally, there is the argument option. And this argument option is what you want to run the command on. So far, we have just run the command without an argument, and we've also run the command without an option before, as neither of these are requirements usually, though some commands, they may be a requirement. If you do not have an argument, it will generally run the command on your current working directory. With the ls command, by adding an argument, you're specifying where we want the command to be run. In this case, we are specifying that we want the command to be run on our root directory. And so if we open up the command prompt again, we type ls-S and then slash, so this is the command we've just seen. This will run the ls command with the classify option on our root directory. And so we can see within my root directory, we have the various directories, the leg files, some executables, but no specific non-standard files. Sometimes options and arguments are referred to as parameters. A command can be called with more than one option and more than one argument, but a command doesn't always require an argument or option, as I said. You might also sometimes see options being referred to as switches or flags, especially for options that take no argument. In this video, we will stick with using the term option. Now, each part of the command is separated by spaces, but if you forget to put a space between any part of the command, it's going to fail. So, for example, if I type ls-f as one word, it's going to get an error telling us the command is not found. Capitalization is also important. So, for example, the command ls-lowercase s will display the size of files and directories alongside the names, while the ls-capital S will sort files and directories by their size. So if I type ls-s and then my root directory, since it's got more files there, you can see it's put a size. Note that the size is in blocks, which may be different based on your operating system. But if I use ls-capital S, note that I've just used the arrow keys to navigate to an earlier part of the command, backspace the lowercase s. It will instead just order everything by their size. And so we can see that the biggest thing in my root directory was that init file or executable, and you can see it's at the top there. So it's important to be aware of when you're using options, whether the option is capital, uppercase, or lowercase, because they may refer to different options entirely. Now, a few other commonly used options for ls that you might find useful are the dash lowercase l, lowercase t, lowercase r, and lowercase h options. So dash lowercase l, dash lowercase t, dash lowercase r, and dash lowercase h. The dash l option makes the command use the long listing format, which we'll see when we run our command. The dash t option will order the output in chronological order, so t for time. The dash r option reverses the order of the output, so if you use dash t and dash r together, you will have your output ordered in reverse chronological order. So that means the newest file will be at the bottom. And the dash h makes numbers more human readable. So as I mentioned earlier, you can run multiple options as a command. And so we could run all of these options together. And if we do so, we will see it's gone into a long listing format, as I said, which is showing things like the permissions and file ownership and dates and so on. It's ordered them by time in reverse order. So the oldest is at the top, the newest is at the bottom. And then it has converted the numbers to be a more human readable format. And so if we didn't have that H, it would just show the exact number. So that would be like 4,000 or potentially 4,000 something rather, and 16,000. But here, because it's turned them into human readable, it's going to show 16K and 4K, etc. But writing that command like that is a little cumbersome. You can instead just write ls-ltrh when you're using the short form of the command. And this will do exactly the same thing. Oops, if I run it on the same directory, that is. And so ls-ltrh on the root will do the exact same thing as the previous command, which is ls-l space -t -r-h, etc., which is much more convenient to write and type out. Now let's take a look at our desktop directory by running ls-f, the desktop. So ls-f desktop. For the observant among you, you may have noticed that I seem to have typed desktop very quickly. This is because I didn't actually type desktop. Instead, I used a useful function of Unix known as tab completion. Tab completion means that if you are typing something and hit tab, if there's only one valid option you could type, it will autocomplete until there are more than one valid option. If there are more than one valid options, you can hit tab twice and it will list the valid options. For example, so if I type ls-f d, if I hit tab once, nothing will appear because there are multiple valid options. But if I hit it twice, it will list the two valid options. And so if I now type E, so ls-f de, and now hit tab, there's only one valid option, and so we'll fill it. Note that if a directory name desktop, or a symbolic link in my case, does not exist in your current working directory, this command will return an error. Typically, a desktop directory exists in your home directory, which we assume is the current working directory on your bash shell. But depending on your setup or operating system, this may not be the case, which is not the case in mine, which is why I created these symbolic links. But you can either set up a symbolink as I've done, so you can just see step 6 of the Ubuntu LTS terminal setup link in the description, or you can use a different directory which is accessible from your home directory. Now, the output should be a list of all files and subdirectories in your desktop directory, including the shell lesson data, which if you're following along, you will have downloaded from the Unix shell lessons link in the description. Everything in your desktop directory will appear as an icon in your desktop GUI if you're using a standard operating system. Now, organizing things hierarchically helps us keep track of our work, and while it's possible to put hundreds of files in our home directory, just as it's possible to file hundreds of printed papers on our disk, it is much easier to find things when they're organized in sensibly named subdirectories. Now that we know the shell lesson data directory is located in our desktop directory, we can do two things. First, using the same strategy as before, we can look at its contents by passing the directory to the ls command. So I'm using tab completion again to make it faster to type. And so we can see the shell lesson data directory contains two other directories, which are exercise data and North Pacific Gaia. And second, we can actually change the location of our current working directory so that we're no longer located in our home directory. The command to change locations is cd followed by the directory name of the directory we wish to change our working directory to. CD stands for change directory. So let's say we want to move into our exercise data directory. We can use the following series of commands. So first, cd desktop, then cd shell exercise data, then cd exercise data. These commands will move us from our home directory into our desktop directory, then into the shell lesson data directory, then into the exercise data directory. You'll notice that cd doesn't print anything, though you will also have noticed that on my shell prompt, it does actually show our location, which may or may not be the case on yours, again, depending on your setup. This is normal. Many shell commands don't put an output out like this, and cd is one of them, unless you try to cd something that doesn't exist. But if we run pwd, we can confirm that we are in the directory we were trying to move to. And now if we run the ls-f command, -f command in this directory, it will list the contents of our new directory. We now know how to go down the directory tree, but how do we go up? So let's say I want to go back up to the shell lesson data directory. Can I type cd shell lesson data? If I run this command, I'll get an error. Why am I getting this error? This is because cd can only see subdirectories inside your current directory. And so I'm trying to move into a directory above my current directory. But cd is only looking for directories within my current directory. But there is a shortcut that you can use that allow you to move up to the directory above you, and that is cd ... So ... is a special directory name, meaning the directory containing this one, also known as the parent directory. So if we run this command, we will move up to the shell lesson data directory. And so we can run pwd, and we can see we're now in shell lesson data. Now, if we ls-f, again. If we ls-f, we won't see this directory, this ... directory by default. However, if we run the command with -a as well, which stands for show all, it will show all the hidden directories as well as the stand visible ones. So a hidden directory and hidden file is any file that starts with a dot. As you can see, not only does it display that hidden dot directory, which represents the directory above our current one, it also shows another hidden directory, which is just a single period, single dot. This single period represents the current working directory. And so that may seem a bit redundant, but it can be useful for various commands that we'll show later on. If you run the command elsewhere, you may also see other files and directories beginning with a dot. These are often files and directories that are used to configure different programs on your computer. The prefix dot is used to prevent these configuration files from cluttering the terminal when using a standard ls command. These commands are the basics for navigating file systems on your computer, pw, ls, and cd. But let's explore some variations of these commands. So now what happens if you just type cd on its own without any directory? So I type cd, and it doesn't print anything else, though I can see I've moved somewhere because I've gotten rid of that. And so let's type pwd. And we can see that I've moved back to my home directory. So cd without any argument will return you to your home directory, which can be very useful if you get lost in the file system. Now, let's try returning to our exercise data directory from before. Now, last time when we moved to our exercise data directory, we ran a series of commands to get there. But instead, this time, we're just going to run a single command. So now we can do this. This is the equivalent of running cd desktop, cd shell lesson data, cd exercise data. So we've just separated each subdirectory with a slash. And if we run that command, then we can run pwd and see that we're now in that directory, and ls-f, we can see its content. Oops. ls-f, we can see its contents. If we want to move up one level from that data directory, we can again just use our cd ... But let's go back into the exercise directory now. And there's another way that you can just move to any location on your file system from anywhere and not have to worry about the command. It will always work. And so far we've been using what are known as relative paths. So a relative path refers to essentially the directions to get to a directory from your current directory. So those directions will only work from that specific directory, or a directory in the equivalent position in the file structure. There's also what is known as the absolute path to a directory. And so the absolute path refers essentially to its coordinates in the file system. And these coordinates work no matter where you are. And the way that you know if something is an absolute path versus a relative path is because an absolute path will always start with that /. So that. Because, as I mentioned earlier, that / represents the root. So this is saying from the root directory to home, to Anthony, to desktop, to shell lesson data. And so this command will take us to exactly that location, which is one directory up from us. So now if I go pwd, I can see we've moved up the directory. Before we move on to the next part of the lessons, there are two more shortcuts worth being aware of. The first of these is the tilde character, which the shell interprets to refer to the current user's home directory. So, for example, if I wanted to go to cd/home/Anthony, I could instead just type cd tilde. Or if I wanted to go to the desktop from my home directory, I could type cd tilde/desktop. And that will take me to the desktop. However, it is worth noting that tilde only works from the start of a command. And so you can't type something like /tilde/desktop. That just won't work. It'll give you an error. Another shortcut is the dash character, which cd will translate as into the previous directory I was in, which is faster than having to remember and then type the full path. This is a very efficient way of just moving back and forth between two directories. So if I cd to my home directory with just cd, I can now switch between my home directory and the shell lesson data directory with cd dash, And so now I'm back in the shell listen data, which I can see there. Back to home. Back to shell listen data. So now we know how to explore files and directories, but how do we go about creating them? In this section, we'll go over creating files and directories using the exercise data / writing directory as an example. So as we can see, we are still currently in the shell lesson data directory. And so we need to move into the exercise data directory. So cd exercise data writing directory. And let's take a look and see what's inside this directory. And we've got the littlewoman.txt and the haiku.txt. So now let's create a new directory. So first things first, we're going to make a directory and we call it thesis. And so now when we run the ls-f command, we can see we now have a thesis directory. But since we just created it, the directory is empty. Note that make directory is not limited to creating single directories at a time. The -p option allows make directory to create a directory with nested subdirectories in a single operation. So for example, if I go make dir and then -p and then ... we'll just move it, put it into the top level directory project, and we'll call this one data, and then we'll go another directory which we'll call project and /results. And so this command will create a directory on the directory level above us called project. And then within that directory, it will create the directory's data and results. So let's run that command. And now we can go ls-f, and we can use recursive so that we can see both the directories. And so this will allow us to see the project directory, which contains the data, the results, and we'll see that both of those are empty. Using the shell to create a directory is no different than just using a file explorer and right-clicking and making a directory that way. So if you open the current directory using your operating system's graphical file explorer, we can see that these directories exist. So if we go into shell lesson data, exercise data, we can see we've got a project directory which contains data and results, which we just created, and we can see in the writing we've got a thesis directory. When you are creating files and directories, it is good to follow the standard practice when naming them. These standard practices include not using any spaces in the names. Even though spaces can make names more meaningful, spaces are used as separators for arguments in commands, and so they can cause issues when you try to use a file that has, or directory that has spaces in its names in the command. You can get around this a bit by using quotations around the name and doing some other things, but it's best just to avoid having spaces in the names altogether. Don't begin the name of your file with a dash, as a dash represents an option, and so if your file starts with the dash at the start, it will be treated as an option by many commands and will cause you issues that way. Again, you can work around this by using quotes around the names and some other things, but it's best just to avoid. And finally, you should just stick to using letters, numbers, full stops, underscores, and dashes in the names and not use any other special characters, because various special characters can have different meanings at different commands and in the prompt. And so it's best just to avoid them and potentially having things get messed up because of these special characters. All right, now let's move into the new thesis directory that we made. So cd thesis, and we are going to create a file called draft. Now the text editor we are using here is called Nano, and Nano is a very simple plain text editor. And when I say plain text, I mean there's only editing plain text. You can't do things like editing images or tables or other things like that. It is purely for plain text. We use Nano because Nano is very simple and it is native to Unix operating systems, Mac and Linux machines. And so you don't have to install anything else for it. You can use some more powerful text editors potentially, like Emacs or Vim, but they do have a bit of a learning curve, and there are various graphical editors available for different operating systems, such as Gedit and VS Code. Now, with Nano, it is, as I said, just a plain text editor. So we've opened it up now on the file that we named draft.txt, and we're just going to type in something. So let's say hello world. And so this is what we're going to have in our text, in our draft.txt document. And so if you look at the bottom of the screen, you can see the various reminders of commands down here. And so up arrow G, up arrow O, etc. The up arrow represents control. And so these all are control G, control O, control W at the same time. And so if we want to look at the help details for Nano, we can type control G, and it'll bring up the help menu, which will give a more in-depth explanation about what all the controls do. And as you can see at the bottom, it tells us that we can press control X to close this help. So we'll do that. Now we're back at the editor. We want to write this out and then exit. So we're going to use control O to write out. And it asks us, do you want to write it to draft.txt? And we can choose to rename it if we wanted to, but we're going to stick with draft.txt. So we'll press enter. And so now we've written that out and we can exit. And so now, if we type ls, we can see we've got a draft.txt file. Now, if we want to check the draft.txt file has got what we wrote in it, we can just use nano again if we want to. So if I go nano draft.txt, it will open up the text again and we can see it. However, if you just want to do a check, you don't actually necessarily need to open it. It can save you a few clicks. However, you could also use the cat command, which gets its name from concatenate, meaning join together, and it just prints the contents of the file, files one after another. And if there's only going to be one file, like in this case, it's just going to print what contains within that file. And so if we type cat draft.txt, it will print what is contained within the file. Now, in addition to using nano to create files, sometimes you just want to quickly create a file, but you don't actually want to add anything into it yet. And you can do that with another command called touch. And so if I type touch myfile.txt, this will create into existence the myfile.txt file, which will be just completely empty. And so I've run this command now, and I can use ls, and I can see that I've got the myfile.txt. And if I use cat again on the myfile, I can see it's empty. I can open up that same file with nano and edit it and add things in if I want, or feed it into my processes that I have going on that will write out things to those files. But that's just a test to show you can do it. And so let's remove this file because we don't need it. And so we will use the rm command to remove the myfile.txt because it's unnecessary and it just clutters everything up. So now we can see it's gone. You may have noticed that when we've been making our files, we've been generally following the theme of calling it something.something. This is just a convention, though it is an important one. We could technically name our files with extensions anything we wanted to. And so we could call an image file an MP3 file. However, it may cause problems for some of the programs you're using later down the line because some programs will read the extension of a file and use that to determine how to read or run that file, and that might cause problems. Now let's move back into our writing directory. So cd /desktop shell exercise writing. Still using tab completion as I mentioned earlier in the talk. It is very useful for typing much faster, and so we're back now into the writing directory. And so we've created this draft.txt file in our thesis directory, but maybe that name's not ideal, and we want to change it. And we can do that with the move command. Now, the move command will, as the name suggests, move files from one location to another, but by moving a file from its current location to the same location, but changing the name of the file at the destination location, we can also use it to rename files. Thesis, draft, and then thesis, and we can call it quotes, for example, .txt. And so now we've renamed it. And so if we go look inside that directory, we can see we've got this quotes directory. Sorry, this quotes file, quote.txt. However, you should be careful when using the move command, as if there is a file already at the location with the same name, move will just overwrite that file silently. So for example, if I make a file here called, let's see, test.txt, and I'm going to type into it, hello world, hello world. And so Control O to write it out, enter, then Control X. And so I've got this file here with test.txt, which says hello world. And inside thesis, I have the quotes.txt, which just says hello world once. If I were to move the test.txt into thesis, and then quotes.txt, if I were to just move this, I can see that it's gone now, the test.txt, but now looking at the output of our thesis / quotes.txt, it says hello world. And so it overwrote what was originally in that file. And so it is worthwhile being careful about that. First, let's move the quotes file. And so we'll do that with move thesis / quotes.txt to current directory which is represented by the period, the dot. So now when I run this command, we'll see little woman txt, haiku txt, quotes txt, and the thesis directory, which is now empty. The move command can move multiple files at once, and so if we, again checking, we can see these files here. If we want to move the quotes txt and the little woman txt to somewhere else, so we can go move quotes txt, little woman txt, and we can say let's move them to the directory above us. We can see no longer here, but in the directory above us we have the little woman txt and the quotes txt. We can now just move them back. And move them back to our current directory with the command here. And we can see they're back where they started. Not only that, you can use the move command to move entire directories if you want. And so if we use move ... project to here, we can, oops. Oh, I've got a shortcut for ls, which is just L, that you can see the project directory and its subdirectories have now been moved. But let's move that back to where it came from. So moving project, and we're going to move it to the directory above us. So it's no longer here, but it is back in the directory above us. The move command can work almost instantly within a single file system because it's not actually moving the file's physical location in the file system. It is instead merely changing the pointer to the data's location in that file system. And so it didn't need to read and write all those files or directories. And now we're going to talk about copying files. Now we'll use the copy command, or CP, which works very similar to MV, except instead of moving files, it will copy them. So let's copy a file. So copy quotes.txt, and we're going to copy it into thesis, and we're going to rename it something while we're at it. And so now we're going to copy the quotes.txt file into our thesis directory and rename it, that copy, to quotations.txt. And so when we run this command, we can see that we still have the quotes file in our current directory, and then, but in the thesis file, we have this quotations file. Like move, we can also copy entire directory structures. However, if we want to use copy on directory structures, we have to also use the recursive option. So we're going to copy thesis, and we're going to copy it to thesis backup. And so the reason we have to use the recursive option for copy and not move is because, as I mentioned with move, you're not actually moving the files. You're just changing the address, essentially. It's still in the same place in the file system, unchanged. But with copy, every single directory and file needs to be read and then written to a new location in the file system. So that requires you to recursively run the command. And so here we now see that we've got a thesis and a thesis backup. And so if we do ls thesis and then thesis backup, we can see they're the same, except for they've got a different directory name. If you try to do this command without the recursive, so you're going to get an error, which says the -r not specified, omitting directory thesis, because it wasn't done recursively. Now let's clean up this directory a little bit by removing the quotestum.txt file, since we already have a copy in our thesis and thesis backup now. And so we've removed this, and it's gone. It is important to be aware when you're using the rm command that you don't have something like a recycling bin. When you rm something, it is essentially gone forever. You're unlinking it in your file system. This means that your operating system now knows it can overwrite those files with other things. There are some softwares and tools that you can use to potentially retrieve deleted files, but it's not guaranteed to work, because as soon as you remove a file with rm, that unlinking happens, and it could have instantly been overwritten by something else, or partially overwritten anyway. You can also remove directories. However, if you try to remove a directory, you'll get a error like this. To remove a directory, you have to again use the recursive flag, the recursive option on the command. However, if you use rm with the recursive option, you should be extremely careful, because if you're not conscientious about using it, you could remove data that's important. One way to safely use rm recursively is to also use the -i option. So rm-r-i. And so what this will do when we run it is it's going to prompt us at every instance of confirming whether we want to delete individual files. And so if I do this now, it says, do you want to descend into thesis to check out the files you want to delete? So I have to type yes. Do I want to delete the quotations.txt? I can say no, I don't want to delete that. Do I want to delete the directory itself? I do not want to, so I'll press no. Like the move command, you can copy and move multiple files at once. And so if we were to, let's say, copy the haiku and the little woman txt, and we're going to move into the directory above us, we can see that we've got the haiku and the little woman txt there, and then we can remove them. Haiku and little woman. And so now, if we look in that directory above us, they're gone. Sometimes you'll need to copy or move several files at once. This can be done by providing a list of individual file names, or alternatively, you can use something else which are known as wildcards. So wildcards are special characters that can be used to represent unknown characters or sets of characters in a file name within the Unix file system. And so, so let's move into the alkanes directory. And within the alkanes directory, we can see all these files. A wildcard will allow you to specify a subset of files without knowing all the names of those files explicitly. And so, for example, if I use ls star, which is the wildcard, .pdb, the star will expand out to be 0 to infinite characters, but ending with the .pdb. So anything that ends with the .pdb in this directory will be listed. And so that will be all the files in this case. But you don't have to necessarily have the star at the start. You can have it at any point. And so we can, for example, use ls p star.pdb, and this will instead list only the files that start with a P and end with a PDB, which are pentane and propane. But that wildcard, the star wildcard, will expand out into an unlimited amount of characters. You may have a known amount of characters which you want to only include. And so in cases like that, you can use the question mark. And so now instead we can use ls question mark ethane .pdb. And this will instead only show entries that match this exactly, except for the except they have one character at the start. And so that only represents methane. So the star, if we use the star, we'll see ethane or methane, because the star could be 0 characters. It could be 0 characters, it could be 1 character, it could be 100 characters. But the question mark is always 1 character. It says there is one unknown character. Show me everything that matches the rest of this plus this one unknown character. And if you want to, you can use multiple question marks. And so we could use question, ain.pdb. And this is saying, show us the things that match ain.pdb and start with 3 characters exactly. And so that comes up to cubane, ethane, and octane. When the shell sees a wildcard, it expands the wildcard to create a list of matching file names before running the preceding commands. But as an exception, if a wildcard expression doesn't match any file name, Bash will then pass the expression as an argument to the command as it is. So for example, if we type ls star.pdf, there are no files in this directory that end with a .pdf. And so it will first try to expand that and see if there's anything that could be matching. It won't find anything, and then it's going to run the command itself as star.pdf. So that concludes the first 3 lessons for the introduction to Unix software carpentry lessons. We will produce another video in the near future, which will cover the remaining lessons. But these first 3 lessons should cover the basic Unix commands that you require to get up and running on the NESI platforms.